the general form is root of 1 plus 1 by n square plus 1 by n plus 1 whole square. So we need to simplify it. So as a part of simplification, you just took LCM. See, if you took LCM, what will happen? The LCM is n square of n plus 1 whole square under the square root. And since here it is 1, we need to multiply this n square into n plus 1 whole square with this one. And you will get that n square into n plus 1 whole square. Plus, see, n square is there. So you need to use n plus 1 square. Plus, and n plus 1 square, so here we need to write n square. So at the end, under the square root, you need to simplify this. In the denominator, it is the squares of n and n plus 1 square. So square root and that square will get cancelled ultimately. But what to say about the numerator? We need to simplify that numerator. Okay? Yeah. What is that numerator? How can I simplify? So for the part of simplification, first of all, I just do multiply everything. Okay? Under the square root, see, n square, n plus 1 whole square is a common thing for these two. So n plus 1 whole square is n square plus 2n plus 1. And if you common it out, still you left with n square plus 1 plus n square. Okay. Divided by n square of n plus 1 whole square. And this is equals to, and the next step, n square plus 2n plus 1 into n square plus 1. So what I am doing, what I do is n square plus 1 with this n square plus 1, 2n with this n square plus 1. If I multiply, what will happen? You just look there. See, this is equals to square root of n square plus 1 with this n square plus 1 will become n square plus 1 whole square. Plus, and now this 2n with this n square plus 1 will become 2n times of n square plus 1. Plus, here what I have? N square. In the denominator, n square into n plus 1 whole square. Okay. Now you just look at the numerator. See, something like x square, and here it is some y square, and they are like 2xy. So the numerator, if you think, this is equals to square root of n plus n square plus 1 whole square. Okay, n and n square plus 1 whole square divided by n square of n plus 1 square. See, everything is under the square root. So if you remove those squares with the square root, you left with n square plus n plus 1 divided by n into n plus 1. And further, if you simplify, this n square plus n is nothing but n into n plus 1 plus 1 divided by n into n plus 1. And this n into n plus 1 with this n into n plus 1 will become 1 plus 1 by n into n plus 1. So at the end, the general form of that root of 1 by 1 square plus 1 by n plus 1 whole square leads to 1 plus 1 by n into n plus 1. Using this format, we need to write everything and then we need to add. Just have a look. Look there. We simplified the general form of that root of 1 plus 1 by n square plus 1 by n plus 1 whole square as 1 plus 1 by n into n plus 1. And now the given problem is first term n is 1. So 1 plus 1 by 1 into 2. This is the first term. Plus, whereas the second term 1 plus 1 by 2 into 3. And whereas the third term 1 plus 1 by 3 into 4. Like that, if you proceed, the last term 1 plus 1 by 999 into 1000. Okay. At the end, we need to add all these things. 1, 1, 1, 1. If you collect, how many ones will be there? How many terms are there here? Starting from 1 up to 999. So there are only 999 terms. So since we are adding ones for 999 times, so that is 999. 1 by 1 into 2 plus 1 by 2 into 3 plus and so on plus 1 by 999 into 1000. And that is equals to 999 plus, and we are very familiar with this simplification. Okay, either from the progressions or from the basic fractions. See, this simplified value is again what? 1 minus 1 by 1000. And if you add this 999 with this result, it gives you that 1000 minus 1 by 1000. So at the end, if you simplify it, that's your answer. Is it right? If you simplify 1000 and 1000 is 10 power 6, 10 power 6 minus 1 divided by 10 cube. Okay, that's your final answer for this problem. Just have a look.